Hello guys, good morning and a happy Sunday. Now the question says that the catalytic decomposition of hydrogen peroxide can be followed by measuring the volume liberated in a gas breath. From such an experiment, it was found that the concentration of hydrogen peroxide remaining after 65 minutes, expressed as volume in milliliters of gas involved, was 9.60 from an initial concentration of 57.90. Now in this case, we have the initial concentration given. The initial concentration was what? CO, which is given as 57.90. Now the concentration remaining was 9.60. that is, final concentration is 9.60. now the question says the time interval to reach 9.60 is 65 minutes. Okay, now the question says calculate the first order velocity constant. Calculate the first order velocity constant. Now the first order velocity constant is given by the formula. Now the first order velocity constant was given by the formula K is equal to 2.303. then you have log CO all over C divided by K. Log CO all over C divided by K. Now if you follow it through with this principle, or if you follow it through with this is all over K. To calculate for our K, we already know our CO and we already know our C. Okay, divided by T, not K, rather divided by T, not K. So we already know all our parameters here. You know your CO, you know your C. So substituting in, you have K is 2.303 all over. Your time is how many minutes? Your time is 65 minutes. It means that your K will be in minutes. Okay, 65 minutes times log CO is what? The initial concentration 57.90 all over. C is what? 9.60. Now when you calculate this, what are you going to have? You have K is equal to, you are going to have, if this 2.303 divides 65, is going to give us 0.0354. then we have times log. Now if this 57.90 divide 9.60 is going to give us 6.031. now find the log 6.031. what is it going to give to us? Now log 6.031, it will give us, this will be 0.0354. I'm rewriting this, times log of this. The log of this will give us, that should be 0.7803. So at the end of the day, what do? You multiply these two together. Okay, when you multiply these two together, what is it going to give to you? Times, that's 0.0354 to give us 0.027 per minute. So that will be the constant. Okay, 0.027 per minute will be the constant, which is the first question here. Calculate the constant. So that will be the constant. Now that you have gotten the constant, the next step is to calculate how much of H2O to remain undecomposed after 25 minutes. They are telling you to look for C. Now C is unknown after the time 25 minutes. Okay, it means your T now will not be 25 minutes. C is unknown. Of course, CO is still what remains 57.90. Now using that to work, what will be our answer? Let me erase what we have here. If we use that to work now, following the formula given, what will be the answer? That will give us, so we erase everything aside from our value for k. What was the value for k that we just wrote down? The value for k is equals to 0.027 per minute. Okay, now what is your k initially? Your k is 2.303 all over t log co all over c. Okay, now at this point in time, now what can we do? We substitute in all the values except for t values, or we can make t the surrogate of the formula, but that will be a very long process. Or no, we are looking for co, so we miss c here. We are looking for c because they are asking you how many will be what will remain. That means the final concentration. So we are looking for c. We make c the surrogate of the formula, but before we can make c the surrogate of the formula, first of all, let's try and make everything here numbers by substituting in our values. Now, substituting in values, what is the value of k as calculated? This is it. Value for k is 0.027 is equal to 2.303 all over t is how many minutes? 25 minutes. Okay, for the part b of the equation, t was given as 25 minutes, is equal to log, what is your co? 57.90. and what is your c? C is unknown. That is what you are looking for. So at the end of the day, what are you going to have? You divide this and this. Okay, if you divide this and this, or you can cross multiply, but I would prefer that you divide this and this and get your answer. So what would that give to us? Now if you divide that, it's going to give us 0.027 is equal to 0.09212 log 57. This will be log, okay, 57.90 divided by c. Now we are looking for a way to make c surrogate of the formula, so we can divide both sides by what? This, to cancel out this from here. 0.09212 divided by 0.09212. Now when this cancels this divide by this, what are you going to have? This will give us 0.293 is equal to, this cancels this, it will give us 1. Then we have log, here will be what? 57.90 divided by c. Now for us to remove this logarithm from here, what do? Find the antilog of both sides. Okay, we find the antilog of both sides. To remove the logarithm, find the antilog. So the antilog of both sides will be what? Is 10 raised to the power. Antilog is 10 raised to the power of anything. Okay, so 10 raised to the power of 0.293 would be equal to, now the antilog, we cancel this log from here. Okay, please take note of this. The antilog, we cancel the log from here. So what are we left with? We are left with 57/90 divided by c. Now what is the antilog of 0. The antilog will give us 1.963 will be equal to what we have here, 57.90 divided by what? Divided by c. Okay, let me erase from this side so that we'll see space to write on. Finally, what will now be your answer? What will be your answer finally? Your answer would be, if you have, this is 1.93, so let's take it out. 1.963 is equal to 57.90 divided by c. This c is over 1, cross multiply, c multiply this is 1.963, c is equals to 57.90. Divide here, give 1.963, divide here 1.963. When this cancels this, your C will be equal to, this cancels this, what is going to give to us? So it becomes 57.90 divided by 1.963 to give us 29.4. okay, so this will give us 29.49 milliliter. So that would be your answer, 29.49 milliliter, because everything was given to us in milliliters before. 29.49 milliliter. So that was how you got that particular answer, 29.49. I believe the explanation is clear enough. Thank you for your time. Now you have the other part of that question that talks about the half-life. How can we derive the first order half-life? Now, knowing fully well that your K, the constant, is given as 2.303 all over T, then log C over CO. Okay, log CO over C rather. Log CO over C. Now, we are told that the half-life is the time that it takes to reach half of its initial concentration. Okay, the half-life is the time it takes to reach half of its initial concentration. So in that case, that particular concentration now is not the final concentration. Okay, so the final concentration will be what? Half of the what? Initial. Do you understand? The final concentration in this case will be half of the initial concentration. That is what the half-life is all about. So in place of this C, we are going to substitute half of CO into the equation, because the half-life is the time it takes to reach half of the initial concentration. When it reaches half of the initial concentration, that is the final concentration. So we stop there. The reaction does not proceed again. Okay, so what we are going to do now is substitute this into this equation. Wherever you see C, put what? Half CO. Now, but before we can actually do that, we are looking for half-life. So let's make T the surrogate of the formula. When this crosses to here, what are we going to have? We have KT is equal to 2.03. Are we getting it? 2.303. Then log CO all over C. Now, at this point in time, we want to make the surrogate of the formula. So divide both sides by what? K. So K comes here, and then K cancel K. Your T will become 2.03 divided by K, then log CO all over C. Okay, log CO all over C. Now, at this point in time, we are told that the half-life is the time it takes to reach half of the initial concentration, right? So our final concentration now will be represented with half of CO. So this will give us T is equal to 2.03, okay, divided by K, then log, what do we have here? Now, half of CO means what? 0.5 of what? CO, isn't it? So this gives us CO all over 0.5 CO. Now, CO can cancel CO. What are we left with here? 1. So the T half, let me represent it with T half to show that is the half-life, is 2.303 all over K, then log 1 over 0.5, and T raised to the power of T subscript half, which is the half-life, 2.303 divided by K times log. Now 1 over 0.5 is 2. Log 2 will give us what? Let me quickly press my calculator. Log 2 is 0.301. okay, so this will finally give us T raised to the power of half. In place of log 2 now, I can put 0.3010 because of space. So our T raised to the power of half will be equal to, what do we do? Use what is here to multiply this. Okay, use what is here to multiply this. If you use these two to multiply each other, what is it going to give to us? So this is times log 2 times 0.301 0.3010. okay, supposed to be this log 2 bracket, okay, that is correct, times 2.303. now that will give us 0.693. when you use this to multiply this everything all over k. So that was how they got that answer of t half, the half time or the half life is 0.693 divided by k. That was how they got that. Thank you.